Introduce Ben Root. He's going to give you some information about Matplotlib and be awesome. I heard you actually had sent out an email asking for people's problems with Matplotlib. Yeah. He's a brave man, so be nice to him. Anyways, without further ado, Matplotlib. Thank you.
Well, good to see you guys all here. Nice to see a very nice full room today. So just to start off, has anybody here not gotten the IPython notebooks that are all zipped up? There was the one I sent earlier a few days ago that was just one IPython notebook. That's a much earlier version. The ones that are in the zip file is the latest one. And if you can't download it, I have a couple of USB sticks right up here up front that you can grab and just grab it and extract it. Does anybody also here not been able to use IPython notebook this morning? All right, so it seems like you guys are all either running it off your own machines or running it off Wakari or something like that. Okay, good. I'll give a moment for you guys to settle in. As we get people going a bit, just a little bit of background. So I've been a Matplotlib developer since 2010, which around that point, I've been doing Python since about 2009 and was using Matplotlib to display radar images for my PhD work, and kept on pushing the envelope of what Matplotlib could do with some more and more advanced tricks, and kept submitting patches. And finally, John Hunter was like, "Yo, I'm giving you commit rights. Stop annoying us." So that's how I became a developer. And you know what? That's how any of you guys can become a developer too. This is really a great example of how open source software really can come together, because something doesn't work the way you want it to, you can submit a patch through GitHub. You can file a bug report, or you just ping us on the mailing list, and you know what? Things get done. And it really is a nice community effort that really brought Matplotlib to the polish, and the polish that it has right now, and the polish that it continues to get through each version. So for my particular IPython, so if you unzip the zip file that you have, you'll have 5 IPython notebooks and a couple of extra files that are there. We're mainly going to focus on 4 of them. We'll see how we do in time. So from the directory where you extract out the zip file, run IPython notebook. You can, some of you guys in the morning were taught about the pylab equal inline mode. You can do that if you want. You don't have to because of how I structured my notebook. So we're going to fire that up. And you should see all these parts. Another thing that might be a good idea to have up and open is the, not my Gmail account, have the matplotlib.org website up. I would suggest, unless we really want to do a denial of service attack against GitHub, just throughout the next 10 or so minutes, you guys just, whenever you feel like it, go to the gallery page. It downloads about like 50 different images and such that are all high resolution. So if we get everybody to hit it at once, we'll probably be bringing GitHub to its knees, or at least the Wi-Fi network to its knees. So over the next 10 minutes, it might be a good idea, whenever you feel like it, to go to the gallery page. It's from the matplotlib.org website. You'll see up here, you'll see home, downloads, search, examples, gallery, citation, docs. If you go to the gallery at some point in the next 10 minutes, that would be a nice thing to have up. Now, it came up really fast for me because I'm running it off my own laptop, but that's that. All right. A little bit of background for Matplotlib. Just in case anybody didn't know, the creator of Matplotlib, John Hunter, he passed away back in August. He gave a really nice keynote speech last year about the history of Matplotlib, and I really suggest, if you want to get a nice, really thorough background on Matplotlib from the 10 years in development that he took it for, is a really good speech that you can find through some of the links here. Some other, from this main page, you'll also have links to a couple very nice tutorials and other books that have been written about Matplotlib. I suggest them all. They're all very, very good. So the matplotlib.org website is a very good reference to go to start looking for any sort of information. So, all right. Let's get started with the part one with Piplot. In part one of Piplot, there's a thing very, very at the top, PyLab inline. I'm not going to explain too much about what exactly the PyLab mode is. Just shift enter it and everything will be fine later. Just it allows for some things to happen in the background that will make this notebook look really good. So, what is Matplotlib? For those who are not familiar, it is the library used in Python to produce publication quality figures. And so from the bottom up, matter of fact, it was originally developed as an interactive plotting library, in which you say, hey, I want a plot here. It comes up in a little figure window, and you can start doing some things to it and add some more commands and do some more, and it builds up your figures that way, and then you hit save. That was actually the original design, but then John Hunter took it a little bit further, and he made it basically dual purpose. It can be both an interactive plotting library and a static plotting library, in which you build up your figure all in the language, and nothing actually shows up until you finally say show or save directly to an image file. So it has a wide range of uses. We have people using it as a way to embed plotting in their own GTK or Qt apps. And then we have other people who are running it on headless servers to serve out images for people on demand. So it's a wide variety of uses, and that really gives a lot of power for the library. And also the main philosophy of the Matplotlib library is that we intend to give you guys, the users, the most amount of control over your figures. Whatever you see happen to those figures, you can customize it any way you want. We do not stop you from doing it. We give you a lot of powerful defaults so that you don't have to specify everything, but everything is customizable. I've talked a little bit about the documentation. These various links are very, very useful places to go for starting up any questions you have. The gallery. One of the more ingenious ideas John Hunter had was that it was difficult to express what it is you're looking for. And so going to a search engine and saying, how do I see this idea of a plot in my head, but I don't know what it's called. I don't know what these pieces are, stuff like that. You can't really enter that into a Google. I mean, how do I make the line look like this? How do I, he came up with the idea of the gallery. And so the gallery has all of these figures from a wide variety of examples that have been created, all collected in one place. And with that, you can use your eyes and go through that gallery and pick out the bits and pieces of things that you see you want. You go, okay, I want to do that. And you take a look at some of the code to produce that. But I need more control over the, I need multiple axes to show up. You know, you take a look at another example of how to do that, and you bits and pieces of things you put together. You go, oh, I want to highlight behind the plots like this. Okay, and you go and you take a look at how it did it. Now we'll get on to actually making plots. So why are you guys here? Why are you guys here at SciPy? Is because you're wanting to do scientific work. And what's the key thing about scientists? Is to communicate your results. And I'm very much a firm believer of the idea that a picture is worth 1,000 words. So you can have a paper that goes and describes all your results in perfect, minute detail, but not a single picture there, and how many people are going to gloss over your paper? Just about everyone, because they want to see the pretty pictures. And so that's what you guys are all here for, is how to make great-looking presentation quality pictures easily using Python. And so to start, the very, very first thing you're always going to do is you're going to import Piplot. Most important thing, and then the convention is to do matplotlib.pyplot as PLT. Funny story, don't do find and replace the plot command with scatter. Yeah, because then I got a failure. It couldn't import matscatterlib. .pyscatter. Yeah. So what is Piplot? Piplot is the main module where we bring together all of Matplotlib. You don't just import Matplotlib. Matplotlib just simply holds everything together. It doesn't really do anything useful. Matplotlib.pyplot brings it all together under one place. And so this is where you're going to be doing most of your stuff. And there are a lot of functions in the Piplot module. And unfortunately, we do not do an excellent job of organizing it a bit. So that's what I've done here. Is I brought a little bit of organization into it. And wonderful. I tested this out on my own screen, and it looked great. And now it line wraps like mad on this less wide screen. So I do apologize for that. I break the Piplot functions down into three main categories. The first one being how to prep your plot. And I'm not going to go through every single function here, but take a look at a few of them. So the first one here we see is annotate, is how you, autoscale. And autoscaling is something that is a feature that's turned on by default in Matplotlib to automatically scale your view, your limits. You got CLA, CLF, that's clear axes, clear figure. So things that you might need to do that from time to time. CLim, if you're doing something that involves a color map, you can state what the limits are. Again, a lot of these functions you probably won't be using directly, but they're all there available for you. We have margins, we have figure, something you're going to be using a lot. GCA, GCF, GCI. Get current axes, get current figure, and get current image. That there's going to be a concept I'm going to explain about the current figure, current axes, things like that. There's hold. How many people here are coming from a MATLAB background? Raise your hand. Okay. So you guys are probably used to in MATLAB is that hold is off in MATLAB by default. If I do one plot and then I want to do let's say a scatter or a bar plot or something in the same axis, that bar thing replaces the previous one, that's hold off. That's the default in MATLAB. In Matplotlib, hold is on by default. And so you can do many, many plotting commands for the same figure in the same place by default. And so you can set hold to off if you want that MATLAB behavior. I off, I'll talk a little bit about I off and I on. That's interactive mode on and interactive mode off. There's the RC. There's savefig is another command you guys are probably going to get very familiar with. Set CMap. These are SCA, SCI, that's set current axes. There's all these different functions that are available. There's a lot of stuff. And this is just plotting prep. We have the xlim functions. We have xscale, xtix, ylabel, ylim, yscale, ytix. Now your brain's going, ah! And this is just the first category. Hopefully, by the end of this tutorial, this is going to be a whole lot clearer to you. Second category is the plotting function category. Again, there's a lot of these functions. A-course, bar, barbs, bar H, box plot, broken bar H, cohere, contour, contour F, CSD, error bar, event plot, fill, fill between X. I don't know why we have two of those. Hex bin, hist, hist2D, IM show, log, match show, p-color mesh, and the list goes on. These functions will become your friends. And again, this is also another reason why we have the gallery. Because a lot of these names, like there's one down here, SPY. I have no clue what SPY does, but if I go and take a look at the documentation for SPY, I'll see the picture of what it does, and I'll see that picture in the gallery. So if I'm somebody looking for the SPY function, that's great. But I may not have known that it was called SPY. We do stream plots, so if any dynamicists around here, I'm a meteorologist by training, so I like stream plot. Tri-contour, tri-contour F, tri-p-color, those are the tri versions of the other functions, of the equivalent functions. They're used triangulations to do its work. They're pretty nifty for their purpose. Xcore, yeah, we got all sorts of plotting functions. As a matter of fact, that's not even the complete list. That's actually probably about 80% of what the plotting functions that are available. There's actually a few others that, if you dig down into Matplotlib, you can find them. So, yeah. And then you have the plot modifiers. So things that you can do to modify your plot to make them have more information after you have done your plotting. So in particular, one of the more popular ones is annotate. You know, you want to have some sort of box that shows and points an arrow at something or label this or that. You know, you can annotate it. You can have an arrow point at things. You want to have some sort of line that goes across your chart. You know, so you have the ax H line, the ax H span, ax V line, and ax V span to do various things like that. You can label your contour plots. You can add a color bar. You can add a legend. You can do things with your minor ticks. By default, your major ticks are on and your minor ticks are off, so you can turn those things on and off. You can add grids. You can add text. You can add a table. You can add a title to your figure. If you're doing a quiver plot, you can add quiver keys. There's all sorts of things. And again, this isn't even the full list. So, hopefully what I'm going to teach you guys today will enable you to be able to find what it is you're looking for. And that's why I call this this tutorial the anatomy of Matplotlib. It's to give you guys a base understanding of the Matplotlib library so that when you have a question of I need to make this plot how, you'll have a basis for being able to start looking into the documentation, being able to ask the right questions on the mailing list, or being able to figure out the whole thing by yourself. Ready to dive in? So, first things first. All plotting is started in a figure object. The figure object itself doesn't do much, but it is literally the canvas for all your plotting that is done. And so here in this situation, we're just simply going to try executing that, and nothing came up. That's because in Matplotlib, we do not actually start to show anything until you tell us to show anything. For those of you guys coming from the MATLAB background, you may be used to the very first command where you start plotting something, your window shows up, and it's there and it's in your face and all that. We do not actually start showing anything until you ask us to show anything. And that is called the interactive mode being off, and that is the default. You can have the interactive mode on if you want, and some people do. But by default, it is off. And so if you just simply create a figure, nothing's going to show up, and that's okay. Some things you can modify with your figures. There's actually a few other properties, but they don't show up very well in the notebook. But these two, you can set your figure size in inches by passing in a tuple. And you can also specify an integer dots per inch. I think by default is 72 dots per inch, but you can modify that if you want. So here I'm going to show you can set up a figure size being of 10 inches by 4 inches. And note, I'm then going to do a show, plot.show. And now we have ourselves a 10-inch wide figure with 4 inches tall. And that's great. Now you know how to control the shape of your plot. Some people don't really like playing around with, I need to be so many inches this way or something. But they do know their aspect ratio, or there's a nifty little function called plot.figaspect, where you can say I want it to be twice as tall or only half as tall, and you pass that in to fig size, and it'll create a figure for you of the appropriate size. So here I want it to be twice as tall as it is wide, and it came up with an appropriate fig size for you. So it's a nifty little convenient function that I like to use sometimes. So now, if you could, if you got the stuff off of the zip file, if you could open up a file in a separate tab. Yeah, in a separate tab, whatever. It doesn't work through the there it is. It doesn't work through the notebook. The notebook swallows the SVG file. So if we could open up plotdemo.svg. You'll notice that as your mouse moves around, you got the little thing up on the left-hand corner. It's going to tell you what you're pointing at with your mouse. So here it's called the Y label. These are Y tick labels. This is the X-axis spline bottom, the X-axis spine top, or spine top, sorry. X-axis spine right. We have the legend. This is the super title, axis title, we have a whole bunch of things. A few things aren't coming up, but these are the ticks. These are tick labels. So this kind of helps you understand what the different things are called in a figure. So there's particular names, so it's nice and useful to know that. So good to have that around. So now that we know what particular things are called, what goes in your figure? It's called an axes object. And so an axes object can only be in one figure. And the axes object is where all the plotting happens. So here we're going to do an example where we're creating a figure, then we're going to add a subplot. You MATLAB people, you may like this. We accept the argument of 1, 1, 1. So what that means is I want it to be one row, one column, and give me the first one. People who aren't coming from MATLAB, don't worry, we have other ways to add an axes. It's just that John Hunter, when he originally designed all this, he was coming from a MATLAB background as well, and so he wanted things to work smoothly for that transition. So you add an axes object, and from the axes object, you're going to do a plotting. And so here, just some really simple data. So I want at x 1, 2, 3, 4, I want value at y of 10, 20, 25, 30. And I'm going to set the limits on the x-axis be between 0.5 and 4.5 because I can. So, and then finally plot.show. Because nothing will happen until you do show. And voila.
Which is your axes object, your AX?
AX.
And so that subplot obviously produces an axes object, correct?
The ax object is the axes. The AX variable is the axes object.
Right, okay.
So when I did fig.addSubplot, addSubplot is adding an axes.
That's right, that was my question.
Yes, yes.
Thank you.
I'll go when I go down a little further. There is a subtle distinction between a subplot axes and an axes, but for all intents and purposes, we can treat them the same. All right. There's a very, very minor difference.
Could you briefly say something about the distinction between this approach, which is explicit about creating a figure and then the subplot and then addressing the axis, versus the shortcut that you often see where you just go straight to plot and it creates everything for you? I assume it's doing a lot of this under the hood. I don't know how you reference the objects like the axis and so on.
Right.
Explicitly how you've done that.
So what you're asking is basically you're asking about the Pylab mode.
Well, I'm thinking Piplot. But,
Oh, well, Piplot, and I will talk a little bit more about Piplot, but there's three common ways of doing a plot. There's the Pylab mode, which I'm not going to go into too much. There's nothing wrong with Pylab, but if you really want to be serious about your plotting and stuff, I would avoid Pylab. It's really nice for your interactive stuff, being able to say, hey, plot. It comes down. Then there's Piplot, where the idea with Piplot is that a lot of these commands you'll see, the commands I talked about earlier in those tables that were wrapped, text wrapped, all those commands come off the Piplot module. What they do is when you execute those, they will operate on the assumed implicit current figure or the current axes or the current image. And so you don't have direct control over what it is that they're going to do. And so as your program grows in complexity and you start producing more and more complex plots, or you're using Matplotlib for more and more advanced things, or you're producing, let's say, a library let's say you make a library for your coworkers or something, and you say, oh, just call this function. Well, if you make some function that makes a very nice, pretty graph, but you don't pass it the axes object, it's going to just go and start doing it on whatever the current axis is. Well, that may or may not be what your coworkers want or what your users of your library want. So what ends up happening is that with PEP20, if you guys are familiar with the PEPs, is that PEP20 is the 20 very important pieces of advice, of which only 19 are written. One of them is explicit is better than implicit. And so that's why I really like doing my Matplotlib coding this way, because I'm saying explicitly that I want this figure, and I want this ax object. Whereas PyPlot mode is fine for nice, short, concise things, maybe not in a library, you may not have it in a sub-function or something like that, and you just want to quickly create a plot and you don't care about interactions with possibly other plots. So that's where the difference is. They all work, it's just one is implicit while the other is explicit.
So I guess the essence of my question, though, is if you do it implicitly, is there any way to then access the underlying objects, or are they just kind of hidden to view?
There's always ways to access it. So there's the pyplot.sca set current axis, so you can actually explicitly set an axis that you want. So when you create axes, you can actually, when you create a figure, you can actually assign a name to the figure, and so you can actually then set a current figure, which will then grab its current axes, and then so there's this huge tree hierarchy of things, and again, people coming from the MATLAB background are now starting to go, yeah, actually, I've seen some of these things in MATLAB. That's exactly where it came from. So we try to follow a lot of those rules as well with this. But that's the implicit thing, and you can always override that at any time. We give you full control. So you notice here that I did an ax.setXlim. Well, just about every single function you can call, every single method that you can call from the axes object, you can also call it from PyPlot and vice versa. So the equivalent to this example here is this three-liner, which, getting back to what you were saying, is, why not do this three-liner? It's a lot shorter, is probably a lot easier to understand, and it produces the same exact result. Well, it all goes into whether you want it, whether you're willing to sacrifice the explicitness for conciseness, or whether you need the full control. So depending on how your style is of your code, one may suit you better than the other. A lot of my examples are going to be explicit because I personally do follow the rule of explicit better than implicit. So notice, so this plot here, it had its limits at 0.5 to 4.5 on the x-axis. But I didn't set what the limits would be on the y-axis. It figured it out automatically. This is the auto-scaling feature of Matplotlib. So it knew that my data went from 10 to 30. And so it set my limits to being 10 to 30 on the y-axis. But it let me override it with the x-axis when I said I want it set a certain way. So here, let's take a look at what happens. I'm going to do two plots. I'm going to have two axes objects. I'll talk a little bit more about how to have multiple axes objects in a moment. But I'm going to have a plot and then a scatter of different data. And we're going to see what happens here. So you see that with the line plot, there really isn't much of any margins for this data. It goes, the axes limits are set to be really right up to the edge. You got a bit of a margin here, but that's only because the y-axis, they wanted to set to round integer numbers rather than some arbitrary, some other arbitrary thing. I'll talk about the tick locator later. But then with the scatter plot, it gave it a bit of a margin. So it went, from -15 rather than -5 or -10. So it gave itself a little bit of a margin, and kind of helps keep everything within your view. So we kind of felt that scatter plots and some other types of plot needed that margin, but line plots, you want it to be nice and tight. Margins are something you can modify if you want. I won't get into that later, but there are ways to mess around with it, but that's what they're called. They're called data margins. So now, but that's the auto scaling. If I want to say explicitly how I want to plot something, I can say that I want to set the y limit at the bottom to be -10. I mean, right now it's -4. And I want the x limit on the right to be 25. Note, we're doing these settings after we do the plotting. And look, I only specified half of everything. I didn't specify both ends of the limit. I only specified one, and it allowed it to auto-scale the other end. So it still went to 4 on the upper part of the limit. It still started at -15 there. It still went to -10 for the line plot. So all that stuff still worked exactly as you expect it to. It's just whatever you told it to do explicitly, your wish is your command. Or your wish is Matplotlib's command. So now, just to show you what happens if you try to set your limits before you plot, basically, whenever you do set your limits, by setting your limits, you're turning off auto-scaling under the hood, so it stops trying to auto-scale. So whatever the limits were when it started, it's going to be stuck with that. And so by default, before any auto-scaling or anything, your limits are 0 to 1. And so here you see the y-axis, the upper part is at 1. And yeah, it just doesn't look right. So you want to set your limits after you've finished doing all your plotting. So for any meteorologists here in the room, or geologists or whoever, who want to have your limits go the opposite direction. So rather than increasing with height, you want it decreasing with height. Meteorologists do this all the time with plotting our pressures vertically, because pressure decreases with height. So I want you guys to take a moment, do an exercise, try to make a plot that just simply has it go from 1,000 to 500 on the y limit. It's rather easy if you think about it, right?
Yeah. I actually didn't expect that to work.
This was one of the nice surprises I had the first time I started using Matplotlib. It's like, oh, wow, that works. Anybody stumped? Well, there's two ways you can do it. I'm going to show you the most simple way. That's it. Your limit started at 1,000, ends at 500. All you have to do is flip the order. So a lot of people would have done 500 through 1,000 and just not think about it. But if you want your axes to go in the reverse direction, that's all you need to do. And all your data will plot perfectly fine. There's nothing special you need to do about your data. Matplotlib will handle it for you. Any questions on this? This is actually, limits are actually surprisingly something that a lot of people get a little confused about because it's so deceptively easy. Mm-hmm.
Did you say there was another way to do it?
Yes. Thank you. bottom equal 1,000, top equal 500. So you can have that in any order you want because they're what's known as keyword arguments. So the order, basically they're equivalent to dictionaries in Python, so the order doesn't matter. So you say top 500 is still reversed like that. Because now you're saying explicitly that I want the bottom of it to be 1,000 and the top of it to be 500. And then you can do right and left as well for the x-axis.
I have a question earlier on. So with that function plot.subplots, we return the figure and axis x1 and x2 as object. Can you explain that a little bit? Because
In a moment, I'll get more into that function. You're talking about the one that happened a few examples ago?
Because there is a hierarchy you explained earlier, and then you return them at the same time.
Yeah, I'll get into more detail of that in a moment. So, any other? All right. So one thing that's also nice about Matplotlib is just about anything in Matplotlib can be labeled somehow. So in particular, you want an easy way to make a legend. Well, this is, well, rather easy to do. So here, we create our figure, we add a subplot, and now we're going to plot two pieces of data. I just made up some random data. And I gave a label equal Philadelphia and a label equal Boston. I set a Y label, so I'm going to label the Y axis. I'm going to set the X label. I'm going to label the X axis. And another type of label is the title of the axes object itself. And then I'm going to call ax.legend. Because I did that label equal Philadelphia and label equal Boston, Matplotlib is able to automatically help you generate your legend and label it all for you automatically, which I think is just absolutely freaking awesome. So just about any time you do a plot, if you don't specify the label, it will do like item 1 or something like that, item 2. It tries to come up with some default label or it does a blank string, I forget what. Well, hey, this is an IPython notebook, we can find out. There you go, nothing shows up. So,
Do the labels have to be keyword arguments?
yes, the label is a keyword argument. So you have to say label equal, whatever.
Can you position the label off the main graph in case you need to look at it?
Yes. So there's a way we can get it to tell us more. Okay. So you can, places legend at location loc. Labels are a sequence of strings, and loc can be a string or an integer specifying the legend location. So what you can say is, so the location are either you can provide the numbers or you can say one of these strings. And by default, I think it's set for 1. There is the best one, which uses some heuristic that tries to put it out of its way. It's not great, but it sometimes works. So let's see where it would put it. No, put it right down there.
How did you get that drop-down box?
Oh, so what I did was, so I had the command only partly written, so and I typed tab and, oh, it goes, okay, tab, and then I start getting inside the function arguments, and I hit tab again, and then, so this window comes down, and if it's the first time, up on the upper right-hand side, there's like a plus symbol that lets you drop it down even further, and then you can scroll down through it. Mm-hmm. A new feature of IPython notebooks that you didn't know before, right? It's very nifty. And again, all this stuff you can look up in the documentation on matplotlib.org as well. Or if you are familiar enough with PyDoc, you can just type out the command in the command line and just get it that way. So if I wanted to do, just have it on the right, let's say, I could say loc equals right, and there it is. It went off to the right. We give you full control. And then this is the convenient way. There are actually other ways you can specify the location of the legend. I'm not going to go into them, but if you need something like it got to go off the plot, off to the side or something like that, there's some other tricks that can be done. That's more advanced. Ask that question on the mailing list, please. So, and then let's say you want to explicitly state that something is not to be labeled at all. This may not even really be needed anymore now that I thought it created like a default entry or something like that. You can say explicitly no legend underscore, no legend underscore, and it will not put a legend in there for you. A legend entry there. Ticks, tick line, tick labels, and tickers. This is the most common source of confusion on the mailing list, is what is the distinction between these four things. Everyone refers to them as ticks. Whether they're referring to the tick label or their ticker or the tick line, they all say ticks. There's a distinction between these four things. A tick is the location of the tick label. So you say that this tick is at 5. Tick line is the actual visual representation of that tick. A tick label is what goes below it or to the side of it that labels that tick line. And then a ticker is an underlying object that is in Matplotlib to help determine what ticks to put in your plot. So it's the one that determined that, oh, we're going to need to put a tick at 0, 5, 10, 15. We have automatic tickers that very intelligently figures out, oh, you want it every 5. No, you want it every 10 or every 25 or something. We have some very intelligent algorithms in there that, based upon your range, tries to give you an axis with about between 5 to 8 ticks. And that's what we try to do. Because you don't want it to be too crowded, but you don't want it to be too sparse. So we try to do a rough heuristic of about 5 to 8 ticks. And so whatever subdivision that would be, that tends to be a pretty decent one. But again, following the rule of Matplotlib, we give you back full control. So if you want to tell us what ticks to put in, we'll put in those ticks.
Is there an option to add subticks?
Minor ticks.
Minor ticks, right?
Yes.
Okay.
Minor tick on. So yes, it does work. That's what they're called. So by default, the major ticks are on. We tend to just call them ticks. And then minor ticks follow the same rules, but they're just minor ticks, and they're usually off by default. Subplots. So now this goes back to your question earlier. So each axes object has to be assigned to one figure object. But a figure can hold multiple axes objects. You can't have an axis belong to multiple figures. That just doesn't make any rational sense whatsoever. Well, at least not to me. But you can have multiple subplots within a figure. And so again, MATLAB users rejoice. You have 1, 2, 1. That means 1 row, 2 columns, and give me the first one. And then you have 1, 2, 2, 1 row, 2 columns, give me the second one. We have other ways for you non-MATLAB people Don't worry, but this is the secret handshake that MATLAB users have. So, here you go. We have a super title that would be the title across, for the figure itself, if you want to have that. We have titles for each axis object. Plotting for any individual axis looks like the plotting that we gave before. So, everything works the same. You just simply told the figure that, hey, now you have 2 axes to display for me. But everything individually still works as you would expect. Now, probably a good idea when you're doing multiple axes like this is to make sure you adjust your figure size, because your figure size looks, the default figure size looks great for a single axis, or 4 axes if you do 2 by 2. But it looks terrible if you do, let's say, 3 in a row, or something like that, because now they're all going to look squished. So adjusting your figure size is probably a good idea, and which is why I like that big aspect function, because I know that I'm going to have, let's say, 3 rows. So I say I want it 3 times tall as wide. Well, that makes sense. So some of the different ways to adding subplots. So there is plot.subplots function. There's plot.subplot function and fig.addSubplot function. Those two are basically equivalent. Those are the 2 functions that the MATLAB users are going to like. There's plot.axes. That's a way to, if you want to explicitly state and have full control over the exact location of the axes, you want to use that. Then there's subplot to grid. That's another special function. Again, you look up the documentation for it, and it explains exactly how it works. And then for those who want to be in an interactive mode, they kind of want to fidget around with the margins and such like that, you can use the subplot tool, and it will bring up this little widget, and you can adjust some sliders, and you can add and adjust some of the margins a bit to try to make things look right for you. There's some spacing tools besides subplot tool to help deal with spacing. So here I'm going to show you guys a 2 by 2 subplot. Note I'm using plot.subplots with an S, not plot.subplot, or AddSubplot, which is what you guys saw earlier with the 1, 2, 2s and the 1, 2, 1s and things like that. So this is the other way that a lot of other people would be happy with. And what plot.subplots does is it returns a figure object and a list of axes objects, and it squeezes them automatically. So if I'm doing a 1 by 2, let's say 1 row and 2 columns of axes, I would get a single list. If I was doing just a 1 row, 1 column of axes object, I would get not a list. I would get a single axes object. So that's the squeeze feature. You can turn that off if you want by saying squeeze equal false. But so here I'm saying I want 2 rows, 2 columns. So this axes is going to be a list of lists of axes objects. And I want the figure size to be 9 inches by 9 inches. And then I'm going to use subplots adjust and fiddle around with some of these numbers. I just picked some numbers, and we'll see what happens here. So now we have ourselves 4 axes spaced out a certain way. Let's fiddle around with some of these numbers here. Let's make the H space, the horizontal spacing, larger. Let's make it 0.5 just for fun of it. So here, spacing, did I mess around H space or? Yeah. The height, H space is the height space, W space is the width space. Yeah. So then the width space, let's make that small. Now you bring them in a lot closer. We have some default values that are reasonable for many situations, but you can, again, we give you back full control. You can make this as tight as you want, or as as spacey as you want. So, getting into that. So here's a situation that sometimes happens. You get something that looks this hideous. Oh my gosh. This used to be a nightmare. And this would happen not too infrequently. Where, because Matplotlib has no layout engine. At least nothing really all that robust. We got some workings of some things, but nothing really great. And so the various axes and the stuff for the axes just kind of spill into each other. They just bump into each other, and it looks absolutely terrible. So, what we have done, and this is a feature that came out in version 1.2, I believe. We may have had some pieces of it in 1.1, but version 1.2, we introduced the concept of the tight layout. And tight layout is defined as the spacing in which the various text and axes object will not overlap each other. The minimum amount of spacing necessary to do that. So now, basically the same exact thing, except at the end, I'm going to call plot.tightLayout. It automatically, keeping the same figure size, it does not change the figure size, it adjusts the shape and the spacing of the various axes object so that the text does not overlap each other. And so let's say you don't have a axes title on some of these, it will know that it's not there, and therefore will try to make it as tight as possible. So let's just quickly kind of show that a bit, where I take away the title of the axes. I run that. You still have a lot of overlapping. Now we run this. See, it still made it nice and tight without the axes title. Oh, and a lot of confusion. There's another feature which I'll get into later called bbox inches equal tight. A lot of people confuse this with tight layout. They're two completely different things, but can often be used to kind of solve the similar problems. So I'll get into what bbox inches tight is, but there's not the same as tight layout. Grid spec is another way of specifying multiple axes in your figure. I'm not going to get too much into it, but it exists. So if you want really advanced things, let's say you want an axis to span multiple rows or multiple columns, something like that, or some other custom, not regular grid types layout, you use grid spec. Another concept that often comes up is called twinning your axes. And what twinning means is I got an axis over here and I got an axis over here, and I want the x-axis or I want the y-axis to behave the same. I want them to always be the same, no matter what. And that's called twinning them. And so it's also known as sharing. So here I'm calling plot.subplots. I say share x equals true, share y equal true. And I'm going to now plot two completely different data. and but one in plot 1, in Ax 1 and one in Ax 2, and I'm going to show that. And notice that they're going to have the same limits. Nifty. If I had turned this off, they would have had their own individual limits that made sense for their own individual plot. I could say to only share X. Share X equals true. And so now they share the same X limits, but not the same Y limits. And for those of you who go into interactive mode, you can zoom in one plot, and any axes that are shared will also zoom in. Or you can pan around, you drag and things like that. The other ones will move too. So it's a really, really nifty feature, for especially in those who do interactive mode stuff. But for non-interactive mode, it's still useful because then you don't have to try to, after the fact, try to figure out what the limits are across all your axes and things like that. It will take care of it for you.
Is there a way to merge those
Hmm?
two plots? Even when they do tight layout, it's close, but it doesn't, the spacing between the two plots.
These two?
Yes.
Well, this doesn't have tight layout turned on. So what would have happened is if I had a Y label here, it would have spilled over onto here, most likely. But if I called tight layout after the fact, it will push those two things apart and make everything look nice and pretty. So yeah, Matplotlib kind of by default just tries to use up as much space as it can to try to make the plot use up much. So, but yet it doesn't really become aware of each other. Tight layout is how it makes the axes aware of each other. Axis spines. So these things here, this box is made up of 4 spines. And you can adjust them around to do special little things. So let's say you didn't want a spine on the right and on the top. You want it to look like that. You can do that. And then notice also here in the lower left-hand corner, they're not touching. That's because I kind of spaced it out a bit. It kind of looks like a different kind of plot. Some people like that. So as an exercise, I want you guys to modify this example here so that we're going to have tick labels on both sides, and I want the tick marks, the tick lines, to go through the spine. So I want it to be both in and out. Give it a shot.
Did everybody get the SciPy notebooks? No. Did you not get it? I think it changed, right? So this is an updated version, right?
Whatever I emailed last night is the same version of what's on there. But the one that I emailed on Saturday is a much older version.
This is exactly a plot I need to make, and I tried something. This is using the share. I have a plot like this, and I get
Oh, them being right up against each other? Well, because your W space is set to
that's
0.
what I want.
You want it to be like that? Oh, but then you don't want that.
Or just put the 0 or 1 in. You know, I can go 1, 5, or just not put anything.
No, what you want is something called AxesGrid. I'll talk about that at the end of.
There is a way to do it. Okay, fine. That's really great.
A lot of questions. The very simple answer is yes, there is a way to do it. The question is, how much effort do you want to put into it? Luckily, there actually is a rather simple way of dealing with that.
Terrific.
The other way also you could deal with it is to actually control what text you want it to actually display.
Try to see if I remember this right. I know. But how many of them are focusing on their own?
So you were told about like 3:30, 3:30.
No.
Should we stop with that? Oh, wow.
There's a break at 3:30-ish?
3:30, I think.
Okay.
Or earlier, actually.
Yeah. We're probably going to do a small little break in a moment. So,
Okay.
and then we'll probably have another one later.
We're taking our food away at 4-ish, so that's just as long as people have a chance to get out there before 4.
Mm-hmm.
It's fine.
Yeah. I always. That's right. Oh, right. That's right. Yeah. Here we go. We're starting to get. You want me to go tick frames, huh?
I used to have to start big patterns at the
Yeah. Yeah, the tick params, yeah. I don't deal too much with this stuff, so it's like, wait a minute.
Oh, so you just make something else to keep us busy for a minute?
Yes.
Oh, nice.
But it's also try to get you guys to go to the website and look up the documentation.
I just Googled it.
Oh, there you go. There's another
Which I
place
guess
to go.
actually, yeah, took me right where you're looking at.
So, yeah, so we got, so what was the Google search that you did? So,
Oh, well, I use like the tab complete on set ticks.
yeah,
and
tick
some
params or, yeah.
And then it had a link to documentation. Like I said, I didn't really Google it. Well, no, I Googled set tick params, that's what I did.
There we go. Direction, in, out. Yep, that's what I was looking for. So,
I think it's just big files, not set. There's no set in that.
hmm?
There's no set, just big files.
Oh,
No, you don't even need to access,
just tick, I just get so used to nearly every single command be set something. I just,
Oh, yeah, because, yeah, I did it like you were about to do it.
yeah. So axis equals y. Then I want it to be, it was direction, that's right. Direction equals both.
in all of them.
Yeah. Let's not worry about these right now. Let's just show the tick going through. There we go. If you look really, really closely, if you look, maybe I can zoom this a bit. If you look really, really closely, you can see the tick mark is actually going through the spine. So that's how you do that. And then you can do just about anything else with the spines you want. So
How do you have grid lines to this plot?
how do you what?
Grid lines to the plot?
Grid, oh,
Grid lines?
oh, grid lines. Oh, that's easy. I know that one. Plot dot grid. And what we'll do is that the grid lines will go to the major ticks. And so whatever your major ticks are, the grid lines will be for that.
Can you show the code you had to get the version, just scroll up?
So it was, yeah, ax.tickparams. I say which axis object that the actions I'm about to do are going to be for, and direction equal in and out. It kind of makes me want to go have a burger.
So when you add the grid line there, that's applying to all of the subplots in the figure, right?
It will do it to the current axes, the GCA.
Okay.
So if I wanted to specify which axes, so ax dot set, is it set major or could have sworn.
Yeah, maybe it's, oh. Oh, that might be, it might be this. No? Okay. I have to take a look at, closer look at the grid command. I don't do grid too often either because I do mostly image plots. I don't have a grid for my stuff, so. But yeah, you can always specify which one gets to grid. I just gotta take a closer look at how. I just know plot.grid, so. Hmm?
Ax.grid is true or false.
No, I think.
I tried that. It did-
The
yeah.
AxesGrid within params, you say access equal to x or y or both. By default, it is both.
Oh, down at the axis, yes.
Ax.grid.
Like y-axis.
No, I just said ax.grid and then params, let's say access equal to.
Oh, gee, it didn't give me. Okay, so true.
No, AxesGrid, access equal to x, access equal to y.
So you have to say x
No,
equal.
access, AXIS. AXIS, I guess. Access.
AXIX. So I say axis.
Yeah. That's all right. Yeah, that's access.
Ah, yeah.
Y
Yep,
is-
there you go. That's how you do it. You got the x things, and then I guess.
And y and both.
Now, would you say like both?
Both, yes.
Yes, axis equals DOTH.
That does both and otherwise.
Here we go. So that's the equivalent. It's impossible for any one person to know everything about it. There's a reason why we have why we have a few developers for this. All right, so just one last thing, and then we'll go on a break. Color bars. So color bars are kind of like legends. Yeah, I shouldn't really have to explain it too much, but what you do is you have a color bar for any what's called a scalar mappable in the jargon of Matplotlib. So something is a mappable, you can have a color bar for it. And so usually those are images, but you can have other types of scalar mappables as well. So here's just one, just doing it with a IM show, just to show a random, just a simple image. You know, there's the color bar, it just came up there by default, like that. So let's say instead you wanted to go horizontal, and you don't like how tall that is. You know, you can do that. You can say that shrink equals, and then some fraction. Then you want a label for the color bar. There you go. And then I even have like little triangles at the top and bottom of the color bar, if you want that. The color at the top and the bottom of the arrow will be the over and the under values, which I'll get into when I talk about color maps later. What can be difficult about color bars is that a lot of people think that it's just another item, just like how you have like all these other items in Matplotlib. It's not. It's a trick. Essentially, all this color bar is another sub-axis, is another subplot in which you do an IM show within it, and then you make the Y label, the Y label be on the right-hand side instead of the left-hand side. Or when it's horizontal, we do it as an X label thing. It's completely a trick. And so therefore it follows a lot of the rules with all other sub-axes, and this can confuse a lot of people when things start going a little weird. In particular, I'll show you this. You will most likely run into the situation where you create two plots, but you only want one color bar. And so you create the first one, then the second one, and then you create the color bar. What happened is that the color bar stole some space from the last made axes. And so it made it be smaller because it stole the space from it. There are some ways, and so you go, well, how do I solve that problem? Well, there's some tricks. I think this will work in 1.2. Please work. No, it does not work in 1.2. Okay, it's a new feature in 1.3 where you can specify the list of your axes objects. That way it steals a little bit of space from each of them. So 1.2, it does not support that yet, and that's the version that's current. So the version that's coming out really, really soon, Mike Drodebaum will do an announcement on Thursday, I think Thursday or Wednesday, whenever he does his talk, he'll make the official announcement for it. We have version 1.3 right now in release candidate form right now. So if anybody wants to try it out and see if everything works, feel free to submit bug reports. We're on release candidate 4 right now. So, well, when you package it wrong, you have to put out another release candidate, and it's just... So, but anyway, so with version 1.3, you'll be able to say ax equals and then give it the list of the axes object that you want it to steal space from. That way it doesn't steal it all from one of them. It steals it from a little bit from a bunch of them, so it doesn't look crazy. Other solutions I'll talk about later called AxesGrid. Very, very nifty tool. I love it, love it. Very, very good. Somebody here read the documentation. Correct. It is AxesGrid 1. Yes. We kind of just say AxesGrid due to that's what it used to be called. So, but yes, it is AxesGrid 1. And that tool is just such a useful tool to help deal with these plots, as I will talk about later. All right, I think it might be good to have a little break before we move on to the next section, if you guys want, or if we just keep forging on. Break? All right. About 5 or 10 minutes.